Hello everyone, welcome to Hudson Engineering Academy. It is me, your tutor Hudson, and today we're going to have one important lab experiment. As you can see in our lab today, we're going to determine the density of an hydraulic cement. That will in turn give us what we call the specific gravity of cement. So how, in a simple way, can you determine the specific gravity of cement? With me here, I have what we call the Chatelier flask. So with this flask, we can get the density of cement, which if you remove the units, it gives us what we call the specific gravity of cement. Because for instance, when you go to site where you need to do the construction, but you need to know how to do the mix design, but you need the specific gravity of cement. If you have this flask, it is quite easy to do it. Now, I will take you through the procedures that you need to do. First of all, before we continue to the procedures, what are some of the required apparatus and the instruments or the materials that we need? The first thing that we need is the Chatelier flask. As you can see, the shape, the dimensions here, like here you can see this one and this one and this part. Okay, so you need to know how it looks like. If here is 50, here is 90 in terms of the diameter. Okay, so allow me to take you through the next, that is to say, this is what we call the kerosene. The question is, why do we use kerosene? As I explained in one of my videos about the property of kerosene on soil, but in today we're using it on cement. Kerosene is non-polar, and we use it because we don't want it to react with what? With the cement that we're going to use. First of all, we are having another material which is cement, and this cement, the moment it get in touch or in contact with water, it will what? Start the process of hydration. So we don't want that reaction to take place. We want something which is non-polar, because what do we need? The principle of this procedure is we need to find the volume that will be displaced by what? The volume of the kerosene that will be displaced by the cement. So if that's what we need to do, we need to get a particular amount of cement, then we put it into this flask. So in the first procedure that we're going to do is, first obtain your flask, then ensure that the flask is dry. Okay, as you can see, inside, outside, it is fully what? Dry. If it is dry, take your material. The material that we have here, we already have the cement, we already have the what? The kerosene. In a measured amount, you're supposed to have the 64 according to what? According to the codal expression. And which code is that? It is IS code 4031. So if you read IS code 4031, it will give you all the procedures that you need to perform this what? This experiment. Now, you take 64 grams of what? Of cement. 64 grams of cement, then with your kerosene. So the second thing is that you have to fill this flask, which is fully dried, with kerosene. But the question is, to what amount do you need to fill this? You have to fill this until it reaches a mark in between 0 and 1. As you can see that this is marked from 0 to 1 in between here. So we have to fill this until the kerosene level is in between these two marks. Okay, so let's have that one done. Let's have it done so that we can continue with this procedure. That's the first thing you have to do, to make sure that it is filled up to that mark. So if you see, the mark is up to 1, but you have to do it carefully. It's to be in between 0 to 1. Okay, so as you can see, that's the first thing that we have done. So after doing that, you have to allow it for some time so that the amount of kerosene which was dripping through this should dry. Okay, because when you're putting your cement, if it's not dry, it will tend to stick on this one, on this part. So what you do after obtaining that, you have to record that value, that our initial reading, this is the initial reading when we have not put the amount of cement inside it. So you have to record it. And so the temperature that we have in our first trial or first test is 25 and according to the code, it's supposed to be 25 plus or minus 2. Then the initial reading, we have obtained 1.0, okay? 1.0. Now, we are going to put the cement so that we can obtain the final reading. So let's do that process. So we have realized that it is now dried, so you have to put it carefully so that you fill all this, okay? It's a time-taking thing, but you have to make sure that you do it carefully until everything is done, okay? So you can see that I've chosen to use this thing because it is acting like something to make it easy for me to fill it, okay? Yes. So you have to choose it carefully. You have to fill this until everything enters. The initial one is 1, so we want to see up to which point will it bring us to. So you have to pour everything until it's it is done, okay? Until it is done. So you do everything carefully, as you can see. So you try to shake it. Now, one of the precautions that you need to take is that you ensure that everything has entered, okay? And after it has entered, you put this, close it, then try to tilt it, okay? Try to tilt it so that the cement that had stick to get removed. And here we go, okay? So this is how you put in this. So ensure that stepwise you put it carefully so that you don't miss any of the step. Now we are supposed to take our final readings, okay? Our final readings, and if you can see carefully, this reading is coming to, can show them. This reading is coming to 23.15. Fine. So that means we have to take note of this. Final reading is 23.15. Hope you can see it clearly. Now you have to do the calculation. What is the displaced volume? So this minus this, it will come to 22.15. Now, how do you get the density? The density becomes, let me show you down here. The density is mass by volume, and the mass is 64 grams of cement that we took, okay? Divide by the volume, the displaced volume is what we take, which is 22.15 cc. Fine. So what do we get here? Here the specific gravity comes to 2.89. Now, this is the density. It is 2.89. The codal, this is having the unit gram per cc, okay? But according to the code, when we remove this gram per cc, we remain with 2.89, which is the specific gravity. So this is how we simply do the specific gravity for this, okay? Now we have a task to repeat this for 3 different trials until we get the answers. Then we get the average of the 3 answers. Then that will give us the exact specific gravity of the cement that we're using, okay? So allow me to do this for the second time, then we do it for the third time again so that we can obtain all the results.
Okay.
Fine. So this is our second part that we have done, the second trial. As you can see, the initial one that we recorded was coming to 0.8, okay? So this is 0.8. You have to take note of that, okay? Now, as you can see, the final reading, our final reading is coming to 23.1, okay? So we record this one, that this is 23.1. So you do the same thing. You have to do the calculation again. So that means this is coming to 22.3 if you subtract. Then when we calculate using the same formula that we are using here, it is coming to 2.1, 2.8. 2.87. This is having the unit gram per cc, okay? Gram per cc. When you remove that unit away, we remain with specific gravity, which is 2.87, okay? So you have to do for the third trial again. Then we shall get the average, okay? So let me take you through. I will do the third trial and give the values. We have initial one is 0.6. Then the final reading is coming to 22.8, okay? Then we have the difference between the two, 22.2, and then giving us this density of the cement to be 2.88, and according to the code, taking away this unit, we remain with specific gravity of 2.88, and as you can see, okay? So this is the simplest way that we could do to calculate the specific gravity of the cement using the Chatelier flask. So some of the precautions that you need to take is that make sure you use what? Kerosene, which is free from water. The moment it's having some water, then it will definitely react with the cement. Then secondly, ensure that you put your cement carefully so that you avoid the splashes of the cement outside, because if you waste it, then it won't meet the actual weight that you took, which was 64 grams, okay? Then the other thing is that ensure that you are working under the specific room temperature, and make sure that the flask are actually dried up before you start filling up, because if it's not dried up, then those moisture will really affect your result, especially if it's having water, because you cleaned it with water. So this are basically the simple procedures that I wanted to show you how to find the specific gravity of cement. So in case you don't know, but you want to use it in your mix design for any construction, you basically just need this. At least you have to do 3 trials so that you get the average value. The average of the 3 trials will give you what we call the specific gravity of that cement. So thank you so much for watching this video till the end. Please, if the video is helpful, please do like the video, comment, share with your friends, and above all, subscribe to Hudson Engineering Academy so that you don't miss such kind of important content. Thank you.